Okay, in this video I go a little bit deeper in how to add roots, add square roots. And we have 5 square root of 20 plus 5 square root of 45. Now, there's a plus. Now look at the numbers inside the square root. They're different, okay? If they're the same, I don't need to do this, but they're different. So I make my table, and I write each expression on each side. So on one side I have 5 with a square root of 20, and then on the other side I have 5 with a square root of 45. Okay, now I check my multiplication table to see if 20, first let's ignore that one, let's look at the 20. And I say, is that inside the perfect square bubble? Nope, it's not. So I put divided by, remember it's the 20 we're dividing, not the 5, okay? Divide into the 20, the number under the root gets divided into. Okay, so the first number lower than 20 is 16. So 20 divided by 16, I got a decimal, so I hit up, and then I replace 16 with 9. Okay, just delete the 1 and put a 9. Decimal, now go with 4. Okay, and that works. So I drop the 5, okay, and then I may rewrite the square root of 20 as square root 4, square root 5, just like that. Now again, don't take 5 times 4, not yet. You cross out the square root of 4, and you replace that with the integer that times itself is 4, which is 2. 2, 2. Okay, I'll put a little 2 up there. That's a 2 I just put. And then I take the 2 times 5, which is 10. And then I put the square root with the 5 inside. Okay, now, so that's simplified. Now, is 45 in the perfect square bubble? No, I don't think it is. So I put divided by. And 45 divided by 36, because that's the first number, didn't work. So I replaced 36 with 25, didn't work. Then I replaced 25 with 16, didn't work. And I replaced 16 with 9. Delete the 1, just go 9. And I got that to work. So again, I drop the 5, and then I rewrite this as a multiplication of square root of 9, square root of 5. Okay, so 9 is in the perfect square bubble, so I replace it with its equal, which is 3. Okay. And then I take the 3 times the 5 that's out there times this one right here. So I just multiply those. So 5 times 3 is 15, and we got 15 square root 5. Now here's what I've done. What's the same? The same is the square root. They both have 5 underneath them, okay? And what that allows me to do then is to add the 2 numbers outside, plus those. So 10 plus 15 is 25. So it's 25 square roots of 5. Okay, my next one. Look at the numbers under the square root on plus, if you got plus there. And they're different, so again, I make my table. And on one side, I go 3 square root 8 and 9 square root of 50. Okay. So again, is 8 in the bubble? Nope. So I divide into the 8. So 8 by 4, nope. Or yeah, 8 by 4 works. So I drop the 3. And I rewrite the square root of 8. I put 2 square roots. Remember that 3 just drops down. So I rewrite that as square root of 4, square root of 2. And the first square root is replaced with 2. And then I take 3 times 2. Not 3 times 4, 3 times 2, which is 6 square root 2. Okay, now I go over here, I look up 50, and I see 50 is not in the perfect square bubble, so I divide into the 50. So it's 50 I'm going to be dividing, not 9. So divide by 49, didn't work. Divide by 36, didn't work. then 25. Okay, that worked. So I drop my 9, and then I rewrite the 50 in 2 different square roots. I rewrite that as 25 times 2. Okay, so once again, we get rid of the 25. And here's 25, that's 5 and 5. So I replace the square root of 25 with 5. So I take 9 times 5. Not 9 times 25, 9 times 5, which is 45. And I put a square root of 2 next to it. So look at the two expressions. What's the same? The square root of 2. So then that allows me to plus the outside numbers. So 6 plus 45 is 51. So it'd be 51 square roots of 2. Okay, my next problem, look at the numbers under the square root. They're different. Okay. So I have 2 square roots of 12. And in the other expression, we have 3 square roots of 27. So I say, is 12 a perfect square? It's not, so I divide into the 12. Not the 2, not dealing with the 2. The 2 is just going to drop down. And then 12 divided by 9, decimal. Then divided by 4. Okay, that works. So the 2 gets dropped, and I rewrite the square root of 12 in 2 different square roots, and that's going to be 4 and 3. So here's 4, that'd be 2 and 2. So then I take 2 times 2, which is 4, and then square root 3. Okay, now 27, not in the bubble, so I divide into the 27. So 27 divided by 25, that doesn't work out. And then 16 doesn't work out. And then 9, delete the 1, go 9. That does work. So the 3 in the front I just drop down. And I make 2 square roots. And I rewrite that as 9 times 3. 9 goes first, 3 goes second. And we always eliminate that. And I just look up 9, that's 3 by 3. So the square root of 9 is 3. So I multiply the 3's together. 3 times 3 is 9. And I put the square root of 3. So in the two expressions, what's the same? The square root over 3. Don't add the 3's, okay? And then that leaves you to plus 4 plus 9. 4 plus 9 is 13. So 13 square roots of 3. Okay, next one, we got plus again. So look at your square roots. They're different numbers. And my job is to get it so there's the same numbers. So I have 8 square root 5 and then 7 square root 20. So 5's not in the bubble, so I divide into the 5. So I divide 5 by 4, that's first number, didn't work. And anything that's divisible by 1, okay? So I drop my 8, and I rewrite the square root of 5 as the square root of 1 times the square root of 5. So here's my square root of 1, and it's 1, so I just replace square root of 1 with 1, and then 8 times 1 is 8. 8 square roots of 5. Now you notice how it didn't really change from here to here. It's the exact same expression. 8 square root of 5, 8 square root of 5. That's because when you divide by 1, when you get to 1, it's not going to change. That's pretty much what you roll with, is the 8 square root of 5. So if you get decimals on every number until you get to 1, you can just pretty much circle that up there because it's not going to change. Okay, square root 20, so I divide into the 20 because the 20 is not in the bubble. So I take 20 divided by 16, which doesn't work, and then I divide 20 by 9, doesn't work, and then I divide 20 by 4. Okay, that did work. So I drop the 7 down, and I rewrite the 20 into 2 different square roots, and I rewrite it as 4, 5. So the square root of 4 is replaced with 2. And 7 times 2 is 14. So it'd be 14 square root 5. Okay, so what's the same in the two expressions that have been simplified, this and this? The square root of 5. Okay, and that allows me then to add plus the 8 and the 14. So 8 plus 14 is 22. So I have 22 square roots of 5. Okay, back side. Now this one's a little different. You can do this one the same way, but you're kind of wasting your time because you already have the same number under the square roots. What's the same? The square roots are the same. Okay, and then I can just plus right here. So 6 plus 3 is not 3 plus 6. 3 plus 6. That's 6. 3 plus 6 is 9. So you're like, well, why aren't you making the table? Because I already have the same number under the square root symbol. Okay, if they're already the same, and I'm adding. Okay, I'm good to go. Okay, my next one, I have 9 square roots of 32 plus 5 square roots of 8. Now this time the numbers under the square roots are not the same, so I make my table. So I have 9 square root 32 and 5 square root 8. Okay, so 32, is that in the perfect square bubble? No, I don't think it is. So I divide into the 32, not the 9, the 32. So 32 divided by 25 decimal. 32 divided by 9 decimal. Then by 4. Okay, I got that. Oh, sorry, 32. Yeah, I skipped it. 32 divided by 25. Nope. Then by 16. Okay, that works out. So I take my 9. I just drop that. And then I rewrite the 32 into two different square roots as 16 and 2. Okay, so since 16 is in the bubble, it's 4, because that's the square root of 16 is equal to 4. And then I times the 9 and the 4. So 9 times 4 is 36. And then the square root of 2. Okay. And then 8. 8's not in the bubble, so I divide. So I take 8 divided by 4. That's 2. So I drop my 5. My factor of 5 is just dropped, and the square root of 8 I rewrite as the square root of 4 times the square root of 2. But again, the square root of 4 is replaced with its equal, which is 2. Okay. So I take 2 times 5. 5 times 2, that's 10. Okay, so what did I get as the same? I have the same square root now, the square root of 2. Since those are the same, I can now add the outside plus the outside numbers. So 36 plus 10 is 46. So 46 square roots of 2. Okay, my next one, we got 8 square roots of 6 plus 3 square roots of 24. Okay, so 8 square root 6, and then 3 square roots of 24. Okay, so 6. It's not in there, so I divide into the 6. So 6 divided by 4 is a decimal. And then I run into 1. I mean, you can divide by 1, but it's not going to change. We're going to end up with 8 square root 6. I mean, I'll do the steps. I can rewrite that as square root of 1, square root of 6. But the square root of 1 is just 1, okay? And then 1 times 8 is still 8. So that would be 8 square roots of 6. Didn't change. But you can use the same process if you want. Or if you see that it runs into 1, then it's not going to change. This is what you're going to have. So 24 is not in the bubble, so I divide. So 24 divided by 16 decimal. 24 divided by 9, decimal. And 24 divided by 4 is 6. So I'm going to drop my factor of 3. And I'm going to rewrite the square root of 24 as the square root of 4 and the square root of 6. And the square root of 4 is here, so I rewrite that as an integer of 2, and then 2 gets multiplied by 3. So 3 times 2 is 6, and then we put the square root of 6 behind it. So 3 times 2 is 6, square root 6. So what ended up being the same? Well, what ended up being the same was the square root of 6. So then that allows me to plus the outside numbers. Okay. 8, 6. So I take 8 plus 6, and that's 14. So that's 14 square roots of 6. Okay, then finally, again, you do this anytime you have plus. If you have times, you're going to do 1, 2, 3. But again, plus today, you check the numbers on inside of the square root, and they're different. So we got to come over here and see what we can simplify. So 6 square root 18, 9 square roots of 50. Okay, so 18 is not in the bubble, so I divide into the 18. So I take first 18 divided by 16, decimal, then 18 divided by 9 is 2. So I drop my factor of 6. That's going to be 9, 2. So the square root of 9 is 3. Then I take that 3 times the 6. So 6 times 3 is 18. And then square root 2. Okay, now the 50. 50 is not in the perfect square bubble. So I divide into my 50. So I divide 50 by 49, and that doesn't work. Then by 50 by 36, that doesn't work. And 50 divided by 25, okay, that does work. So I drop my 9, and I rewrite the square root of 50 as the square root of 25 and the square root of 2. So the square root of 25 is replaced with its equal, which is 5. So 9 times 5 then is 45. So I now have my common square root. I have the square root of 2. And again, that allows me to plus the 18 and the 45. And 18 plus 45 is 63. So I end up with 63 square roots of 2.